Let's solve this initial value problem where we have a differential equation and an initial condition. We can put the power 2 separately on all of these terms here to get that the derivative of y is 4x squared y squared. This is a separable equation. It means that if we divide by y squared, we will get that y prime over y squared is 4x squared. Now in the left we have just y, and in the right we have just x. So we can integrate on both sides. Well, in the left we need to integrate something like 1 over y squared. Well, let's think in a more easy way. What if we had to integrate 1 over x squared? This is the same as the integral of x power minus 2. If we integrate, the power of x will increase by 1. So minus 2 plus 1 is minus 1. If we would differentiate this, the power minus 1 would drop to the front. So to compensate with that, let's divide by the power. And we might need to add some constant there also. By using this integration of x, we can find a formula with what we can integrate functions. Well, okay, let's a little bit think. Better to write it in a more simple way. These are minus 1 over x. Let's thinking that way. The derivative of minus 1 over f of x, what is that? It's the derivative of minus f of x to power minus 1. The minus sign will stay there. When we differentiate this, the power minus 1 will drop to the front. The power will decrease by 1. So we obtain that. And I almost forgot the inner derivative. Okay. The derivative of this is this. So the integral of this is this. So now for our equation, the integral in the left is equal to minus 1 over y. In the right hand side we get this. Okay, our function y satisfies this equation. And still we have the initial condition y at 1 is equal to minus 1/2, what we did not use yet. Well, let's solve y from the equation. Let's multiply by minus 1. And let's multiply by y. And let's divide by this term. We get that y is equal to this function. Okay, so this is the general solution. If we want to write this in a little bit different way, then what might we do? We can multiply both the numerator and the denominator by -3, and we would get -3, and in the below 4x cubed plus 3c. Well, this is just some constant. We could call it, for example, capital A. Now we were told that y at 1 is -0.5. Let's try what this gives. -0.5 is y at 1. Well, that's the same as -3 divided by 4 plus a. X cubed is 1 when x is 1. Well, how can this number be -1/2? If the number would be -3/6, then we would get half from here. So it seems that our constant capital A needs to be 2. In this way we would get 6. So for the differential equation, this is the general solution. By using the initial condition, we got that A is equal to 2. So the particular solution is this one.